Hi, welcome back. So we are at the break and continue statements and else clauses on loops. Before I explain this section, I would like to get you to a certain task. Say, for example, I am in a quest to find out if a number is a prime number or not. And now from a mathematical perspective, we know a prime number happens if it's factored by itself and 1 only. So for example, if I would have a range of number from 2 all the way to 10, right? So don't forget we are saying like that. So we got 2, 3, all the way only 9. I want to check is 2 a prime number or not, 3, and so on and so forth. So what kind of strategy can I design to find out whether this number it is or not? So basically I know 2 for sure it's a prime. Why? Because I know it's only multiply of 1, the previous number, right? How about 3? I know has got nothing. If I would have to check the previous number, which is 2, got nothing to do with 3. You can say like 2 multiplied by 1 or 2 by 2 lead me to 3. So I know 3 also is a prime number. How about 4? Now in this case, for example, I would have to check the previous sequence of it, which has 2 and 3. I know that 3 got nothing to lead me to 4 because 3 multiplied by itself or 3 by 1 or 3 by 2 does not lead me to 4. But I know 2, it can lead me to 4. If I multiply 2 by 2, it lead me to 4. So I know that 4, it isn't a prime number. So if I take this number, right, and I divide it, for example, starting with this. If I divide this number 4 by 2, all right, and I get remind of 0, I mean, I got nothing. I'm reminding, this is the sample percent we spoke about it. If I get the remind of 0, right, that means this number, it isn't a prime. And the factor of this number, it happens to be this number, which is in this case 2, multiplied by the result of this division of 4 over 2. And I know 4 over 2 is also 2. So in this case, this isn't a prime number, and it is actually the product of 2 multiplied by 2. Okay, let's take 5. The same strategy. I'm going to start by dividing 5 divided by 2. The remainder, it isn't 0. So I pass. How about 5 by 3? Again, it isn't 0. I pass. 5 by 4, it isn't. So I pass and I stop here, and I know now this is again a prime number. How about 6? Same thing. I would start by 6 over 2. Well, yes, the remainder is 0, and I know that 6 over 2 is a 3. So in this case, I know the product is 2 multiplied by 3 would lead me to 6. And all the way. For example, let's take the last number of 9, all right? Say 9 by 2, it's not a remainder of 0. So I go to the next one. 9 by 3, it's a remainder of 0. So I know 9 by 3, it is a 3. So I know now the product of this is just a 3 multiplied by 3. So I think the concept, I mean, from a logical perspective, is clear to me, and I know how to get around that. Now, I want to convert this solution or this logic into a piece of code. What would I do? What is the approach I would do? First of all, I learned about range. Create a range loop, has a range from 2 all the way to 10. Loop again in a range that start again from 2, and this time up to that number where I am standing right now. In this case, the index of this previous loop. So I'm going to start into this from 2 there. So what I'm going to do, I'm going to try to check if this divided by the first number here. I want you to get me the product, which is equal to, of course, whatever I divided here, like I did, multiply by the outcome of result of that. So this is going to be the product. Once I catch where I am right now, I have to stop, and then I can do something called break. So break from this loop and carry on our next number. In a sense, let me show you exactly what I mean. I'm number 9. So once I'm number 9, I take this number 9 and I get inside this for loop, the second one inside. And here I'm going to say I'm going to start from 2 all the way to 9, right? That's what I did. Now what I'm going to do, take the 9 and divide it by 2, as we said, because he was starting from the range of 2. 9 divided by 2, the remaining is not 0. So pass again to 3, because here from 2 to 9, from 2 to 3, from 2 to 5, depends on where I am standing. So go to 3. 9 over 3, yes, the remainder was 0, then I break. This is what exactly happened. Now, how about the case of getting 5 here, for example? I take 5 divided by 2. It didn't happen. Nothing. Go to 3. 5, 3, nothing. 5 by 4, nothing. So I exhausted this for loop. There is nothing left for me because the range was from 2 up to 5. And it is over. What I'm going to do here, if this didn't reveal any result, I'm going to write here that this number where IU right now, this I number, in this case like the 5 or whatsoever, it is a prime number once again. Now this block here, this block where I am standing right now here, we can use else. Now usually we know that else statement is only strained to the F we use, but actually we can use else also with the for loop. Else here indicate if you exhaust the use within the block, the previous block, and you got nothing to do, I want you to consider it to use this else. And if you find whatever you're looking for within this loop, I want you to use the break. So this is one a practical example to see how to use a break and else. Let's go ahead and translate this into a code. You will get exactly as we expect. 2 is a prime, because just to check it out. So what happened, we started with 2, and I go inside this in new for loop, and I'm saying, okay, create this from 2 to 2 where there is nothing actually to loop. So this didn't happen at all. It's just like it's not valid. So I'm gonna go with the print of this. So 2 is a prime number. Now the first loop becomes 3. Now I have to enter inside this. I'm going to start x in a range from 2 to 3. So there's only one value to loop over it. What I'm going to ask is 3 divided by 2, because here is the value of 3. The n is 3, right? And the x here is 2 because I'm set the first value. Is the remainder is 0? No, it isn't. So if I loop again, there is nothing to loop again. So I am done with this. 3 is a prime number. Now we are in 4. Now I go inside n is 4 now. From 2 to 4. I'm going to ask a question. Is 4 divided by 2 is the first number in this range? Is the remainder 0? It happens to be, oh yes, it is 0. So we're going to print that 4 equals to 2, which is this number 2, now is the first in that range, multiplied by the 4 divided by the 2, the flat number, which is 2. That's what I get. And the last number was, as you can see, it is 9 because after I exhausted, you got 9 by 2. It isn't. Then 9 by 3. Yes, it is. And so on and so forth. I hope this syntax, it makes quite a bit sense to you, because if you start to understand how to translate logic into this bunch of code by using the for, the if, that's why we need to learn that. It doesn't matter. I can take the same logic, apply it to C or C++ or whatever programming language I am up to. Now, one more example I would like to share with you. It's about continue. And what does continue mean? Let's say, for example, I'm going to give you a mission range of number from 2 to 10 again, and tell me whether the number is even or odd. Observe now, I'm just checking the condition, and let's see what happened. Look here, there's a mistake. What is the mistake? That I come with 2, I divided 2 by 2, yes, it is 0, and it's an even number. But when you continue, because we are within the same indentation, also wrote again the same number 2 as an odd number, which is not true. What I wanted him to do, actually, if you capture this an even number, stop here. It's just say break. So you could break from this loop, but it's not going to continue at all the for loop. Then it will stop here. So let me show you what I mean. If you do that, it will just only find 2 and then break. That's where we can use something called continue. Now, what does mean continue? Is exactly as you expect. So we started with number 2. He found it that the remaining is 0. He wrote it's an even number, and then it didn't go to the next, it just continues. So it's a kind of a breaking up to here, but not completely from the loop. You say, go ahead and carry on working on the loop, but up to here, stop. Don't do anything beyond that line. From here towards, it's got to be completely out of execution. That's why I went to 3, and he checked it out. If 3 is not actually the remainder by 2 is 0, That's why, right? 3 is actually an odd number, and then it comes to 4, and so on and so forth. I hope this also concepts are quite clear to you. Now, next we're going to be looking at the past statements. I will see you then.